Hello and welcome back to the CCNA journey with me, Ryan, with this next video on VTP, the VLAN trunking protocol. For those who don't know, you can contact me here on YouTube, Facebook, LinkedIn and Twitter. So in this video we're going to dive into the VLAN trunking protocol, understand why it's needed, and then we'll pick up with some configuration examples. So first of all, knowing that it's called the VLAN trunking protocol, it kind of doesn't do what you would expect it to do. It doesn't trunk your VLANs for you. Instead, it's just a way to allow VLANs to be created on the switches across your network. So the first thing to know about VTP is it is Cisco proprietary. So if you have a mixed vendor environment, you can't use VTP across all those vendors, but you can use VTP on your Cisco switches. Now, the whole purpose of VTP is to propagate the VLAN database, or the VLANs you create, across a local area network, so a LAN. And what do I mean by that? Well, if we have a think about a couple of switches, let's say we have 3 switches, and those 3 switches are connected, all Cisco, in this kind of triangle. And you have, let's say, machines over here in VLAN 10, machines over here also in VLAN 10, and machines over here in VLAN 10. And you want communication to flow between these switches, so ARP and other bits of traffic will work, and in turn so would IP connectivity. Well, what you need to do is log on to each of these switches individually, create VLAN 10 globally by using VLAN 10 command, and then you would normally put these downstream ports into the access mode and access VLAN 10, and communication should, in theory, be successful, providing that the trunks between the switches allow that VLAN. All good. What VTP allows us to do is skip one step of this process. It allows us to, once we create VLAN 10 up here, VLAN 10 is then propagated to all connected Cisco switches. So everyone automatically creates VLAN 10. Now you still need to assign it to the ports, you still need to allow it to the trunks. It's just the initial creation of the VLAN. And if you have, I don't know, 10, 20 switches and you run one command on one switch, it saves a lot of time, so you don't have to keep going to all the other switches and creating that VLAN. Now that was the initial purpose of VTP. The other benefit of VTP is it's not necessarily just the time, but the energy required in troubleshooting. So what do I mean by that? Well, if you're manually going around creating VLAN 10 here, creating VLAN 10 here, and let's say down here you have another switch and you created VLAN 10 here, but you forgot to create VLAN 10 there, then all of a sudden you've broken the communication up for VLAN 10, and devices down here cannot communicate with devices up here. Now in this environment it's pretty straightforward, there's only one switch, but when you have redundant links and multiple switches everywhere, if you forget to create a VLAN on one switch, then you could break the end-to-end communication. So kind of VTP was an attempt to sort of help with the VLAN creation, not the VLAN assignment, in this idea of propagation through our networks. So what benefit does it give us, VTP? Well, it's plug and play configuration when adding new VLANs. So you get a pile of switches from Cisco, brand new, plug them all together, you create one VLAN. Depending on that switch and the VTP configuration, it will start to propagate to the other switches automatically. So as I said, it minimizes the administrative overhead and errors. So if we forget to put a VLAN on a downstream switch, VTP will ensure that VLAN exists on that downstream switch. So we have end-to-end communication, and it's accurate tracking and monitoring of VLANs. So we know if everyone's running VTP and we go on switch A and look at switch A, if it has 10 VLANs, we can make a bold assumption all other switches inside VTP must have the same amount of VLANs. Now to caveat that, at the ICND2 that's accurate, but as you progress further in your sort of career with Cisco and understanding VTP, you start to learn about VTP pruning and different VTP modes where that may not actually be correct. But for now, for us at the ICND2, that is the case. So there are 3 modes for VTP: the server, client, and transparent. Server is the default, and it kind of plays on what I said earlier. Let's say you went on eBay and you bought 3 switches and you connected those switches up in a kind of triangle fashion. Now what normally happens is, first of all, they're all in server mode for VTP, which means that they can all create VLANs. They're all running dynamic desirable mode for DTP. And remember, DTP allows us to actually form trunks on those links between the switches. So all of a sudden, we have by default a propagation of the VLAN database across the network, and they all run some form of spanning tree protocol, something we haven't discussed yet. But ultimately, what Cisco's goal here is to ensure that if you as a engineer bought a couple of switches, plug them together, it should be plug and play overall, and all of these protocols like DTP, VTP, and STP should work together to solve and create you a kind of stable, if you like, layer 2 network that just kind of works. However, as we know from understanding DTP and as we're learning about VTP, the defaults aren't the best practices, but it's at least enough to get you up and running. You know, we learned from the CCNA with DTP, you should really be statically setting your trunks and your access ports. And we're going to learn in VTP that you shouldn't really be using server everywhere. You should be making a lot of use out of client, or if you really want to get rid of VTP, transparent. Now, what do I mean by these different modes? There is a few differences between them. And again, like I said, this is probably going to be the majority of your questions about VTP for the exam, would be around the modes. Now, server, like I said, is the default, and it allows you to create VLANs, delete VLANs, as in using the VLAN command, and it will allow you to propagate out the trunks. Client, you cannot create VLANs. You can only accept stuff from the server. So normally you would have kind of like one server, and every other switch inside that layer 2 network will be set up as clients, and then you go on to this designated server switch and you create your 20 VLANs that you want, for example, and then the client kind of communicates through VTP messages and then knows to create those 20 VLANs. So that's something that the difference between client and server. If you went on to a client switch and tried to create a VLAN, it just simply doesn't let you. It says that, nope, we're in client, it's not going to work. And then we got finally transparent mode, and transparent mode is, as far as VTP v1 and VTP v2 are concerned, transparent mode is basically turning off VTP. Now I say that because VTP v3, which is outside the scope of this CCNA class, is going to be a newer version that allows you to turn off VTP, but in 2 and 1 you cannot turn off VTP. The way you turn it off is by setting it to transparent, and transparent essentially means when you create a VLAN locally, do not propagate it out. So that does mean if we had 10 switches and they're all running VTP transparent, then we'd have to go to every single switch and create that VLAN before we can do anything else. And that goes back to, we may have errors in the network where we forget to set a particular switch. Now the modes themselves we'll go into in a bit more detail, and when we get onto the practical side of VTP, we will investigate the importance of those modes. But high level, server allows you to create VLANs and propagate them out of trunk ports to other downstream or upstream Cisco switches. Client mode does not allow you to create VLANs and accepts VLANs from server mode, and transparent mode is essentially not participating in VTP and allows the VLANs to be created locally. Now it's also worth noting you can have all of your switches as server, one switch as server and all as clients, and when you create that VLAN, all other server switches accept it. It's just you can't create it on clients to the servers. So it doesn't matter how many servers you have, but best practice states you should have one and one only. And that becomes more evident when we move into VTP v3 in later courses. Now there's a real important bit here where we need to understand what VTP is not. And what I mean by that is a lot of people, when they understand VTP, they get a little bit confused, and they need to have a disconnect in their mind between what we call the control plane and what we call the forwarding plane. Now I've got a little quote here, and it's a little bit small, but I'll read it out. It says, "It's not a requirement for Ethernet networks nor to find the broadcast domain, i.e. if one switch is running VTP and another is not, providing they both agree on VLAN number, frames can still be forwarded. It only helps to minimize the control plane of VLAN management." So that sounds interesting, but ultimately what that's trying to say is if we have 3 switches, let's say they're all connecting in some sort of kind of line where one is downstream of another. Let's say this person to the far right is running VTP and the guy to the far left is running VTP, but the person in the middle is not. Well, long as the person in the middle who's running, let's say, transparent, also has that VLAN in their VLAN database and allows it on the chunk port, communication can still communicate. Yeah, the VLAN 10 will still propagate over the network. So what I mean by that is we do not need every switch to be running VTP. VTP does not define where traffic can go. It's only a control mechanism to allow us to create VLANs. So there's a big difference there in kind of understanding the forwarding and the control plane. So a good example of that, let's say we had 4 switches. All 4 of these switches are running in server mode. And over here we've got another vendor, and then we have 2 other switches over here, which is Cisco. Now what happens here is these 2 switches are going to be in a VTP domain, and assuming we allow it, then when we create VLAN 10 on one switch, it will propagate to the other. The VTP message may or may not be sent out of this port, and no doubt this switch will just drop the frame because it's unable to recognize it at layer 2. And then over here we can create the VLAN and everyone's server, so that VLAN gets created. Now if these were all in the same layer 2 network, then VLAN communication here will break unless we go here and create VLAN 10. So we need to go into that vendor switch and create it. The same is true if, instead of it being a vendor switch, the switch is running in transparent. If it's a transparent switch, then we still have to create that VLAN locally, otherwise the communication will fail. Even if the transparent switch passes on the VTP message. So for example, let's say to the far right we create VLAN 20, and the guy next to the one on the right accepts the VLAN 20, sends the VTP message, and this person in the middle who's running transparent mode passes that message on to the other switches, and everyone installs and creates VLAN 20 in their VLAN.dat, and again it's allowed on these trunk ports. Then communication will fail between these kind of 4 switches over here and these 2 switches over here until we manually create VLAN 20 on this transparent switch. So it's that disconnect between understanding the control plane, which is the creation and the management of the VLAN, versus the forwarding plane, which is how the communication actually travels on a per hop or per switch basis. So just something to not be too confused there, but VTP does not control the forwarding. It's just there to help us minimize the actual propagation of VLANs. Now you might be thinking at this point, okay, VTP sounds great, it can save a lot of time, it helps us with troubleshooting if we forget to put a VLAN somewhere. Why is it not used as much as we would expect? And the reason for that is because it's got a bit of a bad reputation for something called VTP bombing. Now, VTP works on a concept of revision numbers. So what do I mean by that? Let's say we have a couple of switches, and let's say these switches are all running in server mode as default, and on these switches we create VLAN 10, and this switch propagates that information to the second switch, who propagates it to the third switch. Well, what happens is every time a change is made, whether that's adding or removing a VLAN from any switch that's a server mode, what happens is there's a revision number, and that revision number gets incremented. So we create a VLAN, revision number is 1. We create another VLAN, everyone agrees the revision number is 2. And we delete the VLAN of 20, then the revision number becomes 3. And when you look at the VTP of all 3 of these switches, they will all tell you that the revision number is currently 3. And it uses the revision number as a method to ensure that it has the latest VTP information. Well, let's say we come along here with a brand new switch, and this switch was in the lab. And in the lab, we played with VTP and we created and removed loads and loads of VLANs. And let's say the revision number for this switch is 20, because that's how many changes were made. And let's say also, even though it had VLAN 20, the end was to delete all the VLANs. So there's only really VLAN 1 on this box, because we deleted all the VLANs because we're going to pull it into the network. And then we connected it to a switch and a trunk was formed. Well, what happens is this person sends out their VTP messages, this switch sends a VTP message back, and they all look at the revision number and says, hang on a minute, there's a person here that's downstream to me and he's got vision number of 20. So he must be a newer database than me. And then it looks at the database and says, that's interesting. All he has is the default VLAN. So what happens here is all these downstream switches deletes their VLAN, moves the revision up to match the other person, which now becomes 21, and then all of a sudden, it becomes 20 because we didn't actually make any changes. All of a sudden, all of these switches now have no VLANs and the network is offline, because everyone that was in VLAN 10 and VLAN 5, well, their VLANs no longer exist. And if the VLAN doesn't exist, the MAC address table doesn't exist, so the network comes off. And that's called VTP bombing, because even though you deleted all the VLANs and you would expect it to be safe to connect to the network, because you didn't lower or reset the revision number, it takes priority over the existing network. Now at this stage you might be thinking, well Ryan, what if it was client? Well, even if it was a client and you connected it into the network, it was still VTP bomb, because this revision number does not check that when the message was received, was it received from a client or was it received from a server. All it looks at is whoever's got the highest number must have the most recent database, and therefore I will use that information and delete what I have. Your next question would be, what if it was transparent? Well, transparent doesn't use revision numbers, and because of that it gets set to 0, and therefore it does not affect the network. So the way to actually reset the revision is to set it to transparent and set it back to server or back to client. That's a good way of resetting the revision. But the point of it is it's very important and very easy to bomb, as in like delete, our entire network by accidentally putting in a switch with a higher revision number. And due to this and kind of mishap, the protocol itself doesn't kind of become very popular, because a lot of people are worried that it's such an easy mistake to make that it would cause a large outage for the small benefit of having VLANs created everywhere. Because remember, with VTP, even though those VLANs are created across all of our switches, we still need to log into those switches and assign the access VLANs and the trunk ports. So it doesn't save us that much time in a sense, it only allows us to create it globally. So because of that, the protocol itself kind of didn't become as popular as people would thought it would be, and in turn does have a bit of a bad reputation. Now in VTP v3, this issue is resolved, and lots of other benefits outside VLANs are added to VTP v3, but again, that's outside the scope of the ICND2. So for now, we need to understand what is VTP, what's its purpose, how does it help us save time, and what's the benefits of it, all the different modes between server, client, and transparent. But also we need to know what are the risks with VTP regarding the VTP bombing, and why is that a risk? Why does a higher revision number cause us a problem? And it's important that you spend a bit of time in the lab creating this and then trying to do a VTP bomb on your switches inside Packet Tracer, which is something we can look at in a later video. So just going to recap on what we've done in this video. We now know what VTP actually is. It's the VLAN trunking protocol, and it allows us to create VLANs and propagate them to other Cisco switches inside our layer 2 broadcast domain. And in turn, if every switch has the VLANs, we should then be able to have some end-to-end communication. We like it because it's simple to use. It works straight out the box. So when you buy a Cisco, it just works. And it helps us with troubleshooting, ensuring that every switch has that VLAN. But there are some concerns with it. We don't like it because it's easy to make a large mistake on the network by doing the VTP bombing, and by default it's a bit of a security risk having the ability for every switch to propagate VLANs everywhere. So you might want to lock it down when you're actually setting it up. And we've also talked about these different modes. We said that there is a server mode where we can actually create VLANs. We said that there is a client mode which kind of accepts those VLANs, and we have a transparent mode which is effectively turning it off and using the local database. Now, a few people, let's say we have something that's worth noting actually, let's say we have a greenfield deployment. And what do I mean by greenfield? Means it's a brand new environment. We've got in our office 20 switches to configure, and we want to get them all configured up and ready for the network. Well, what we could do is we could use VTP to actually create kind of that VLAN network by making sure the VLANs are everywhere by using VTP, and then we could go to each of the switches, turn it to transparent mode, and ship them out. So we could do something like that, as in use VTP to help provision the switches, rather than actually leaving them all in server mode by default. If you didn't want to use VTP in production, but you wanted some of the benefits to help you provision a new network. So that's something to keep in mind there. So again, server create, client can accept, transparent is effectively turning it off. In the next video, we'll jump into the CLI and actually set up some VTP, look at the propagation, create, delete VLANs, and then investigate transparent. I hope this video has been informative. I'd like to thank you for viewing, and if it has been, please do like and subscribe.